Analyze the molecular structure of the reactant, acetylene, C2H2 and C2H2. The two carbon atoms share a carbon-carbon triple bond, and each carbon is also bonded to one hydrogen atom via a single bond, H=CH. Determine the steric number of carbon in C2H2. The steric number is the sum of the number of bonded atoms and the number of lone pairs on the central atom. Each carbon atom has 0 lone pairs and is bonded to exactly 2 atoms, one H and one C, which gives it a steric number of 2. Determine the hybridization of carbon in C2H2. A steric number of 2 corresponds to sp hybridization, resulting in a linear molecular geometry. Analyze the molecular structure of the product, dichloroethene, C2H2Cl2. During reaction 3, the addition of chlorine gas breaks one of the pi bonds of the triple bond, converting it into a carbon-carbon double bond. Each carbon is now bonded to one hydrogen atom, one chlorine atom, and the other carbon atom, ClCH equals CHCl. Determine the steric number of carbon in C2H2Cl2. Each carbon atom still has 0 lone pairs, but is now bonded to exactly 3 atoms, one H, one Cl, and one C, which increases its steric number to 3. Determine the hybridization of carbon in C2H2Cl2. A steric number of 3 corresponds to sp to the power 2 hybridization, resulting in a trigonal planar geometry. Conclude the hybridization change. Comparing the reactant to the product, the hybridization of the carbon atoms changes from sp to sp to the power 2, which directly confirms option A as the correct answer. The correct answer is option A. Yes, it changes from sp to sp2.